Hello, assalamu alaikum. Today, I will talk about the data normality, right? And we'll learn about the theory of data normality, and we'll try to practice using the SPSS software, the one sample Kolmogorov's syndromes test. I mean, simply says that one sample case test, right? So first of all, we need to know what is data normality. Data normality refers to the extent to which a data set follows a normal distribution, right? Okay, also known as the Gaussian distribution. In some cases, it says the white distribution, right? Okay, in a normal distribution, the data is symmetrically distributed around the mean, forming a bell-shaped curve, right? For example, when you go to the your some Hindu religions prayer center, you will show you will see a bell, right, as a very big shape. So this is the bell shape, right? Okay, so if the data is normally distributed, the shape will be bell shape, right? This is fundamentally assumption in many statistical analysis, right? From our childhood, actually, we have already know. Let me know. It's funny, right? And we also, when we practice the statistics or we do the statistical analysis, it's common. Data is normally distributed, right? But to be honest, in real life, getting the normal distribution is quite difficult, right? Data is not always normally distributed. However, when the data is normally distributed, its mean, median, and mode will be the same. For example, mean will be 1, median 1, mode 1, for example, right? So mean, median, mode will be the same. This is the definition of data normality. Okay, there are some, this is a rule of thumb or rule of empirical rules: 68, 95, and 99.7. What it is actually? Honestly, when you have the 68, 95, and 99.7% rule describe how data is distributed in a normal distribution, provide a simple way to understand the spread of data relative to the mean. What does it mean actually? So 68%. In this case, actually, your data will fall into one standard deviation of the mean, right? So this is the mean, I mean the population mean. So you need to deduct one standard deviation, and in the positive side, you need to add one standard deviation. If your data fall in 95%, right? So you need to deduct two standard deviation and add two standard deviation, right? At the same in the similar vein, when your data will fall in 99.7%, then you need to deduct the 3 standard deviation from the mean, and 3 standard deviation you have to add from the mean. What does it mean? Just give me, or let me show you an example. For average height of the student of a classroom and standard deviation is 10, it means when you consider 68, so your range will be from 160 to 180. It means I deducted 10, I mean 1 standard deviation from the mean, and I added 1 standard deviation from the mean, right? So range will be 162, range will be 160 to 180, right? On the other hand, when you consider 95% of people having the height, so you deducted 2 standard deviation, you deducted and also you added 2 standard deviation. It means its range is from 150 to 190, right? On the other hand, when you think about the 99.7%, so you need to deduct 3 standard deviation, and you need to plus in the right side the 3 standard deviation. It means the range will from 140 to 400, right? So I do believe you understand it. What is the rule of 68, 95, and 99.7%, right? So once again, from the mean, you have to deduct or add 1 standard deviation. For 68%, for 95%, you have to deduct and add 2 standard deviation, and sequentially the next one, right? So what is the next one? We also in sometimes actually we calculate the data I mean the perfectly normal distribution using the skewness and kurtosis. So skewness and kurtosis, what it is actually? So you skewness and kurtosis should be ideally fall between the -1 and +1. Once again, -1 to +1. In many cases, to be honest, in many cases, some researchers fall this or calculated this standard deviation when the skewness is kurtosis within the -2 to +2, right? But I have the reference. I noticed in many papers, in many cases, they consider actually the -3 to +3, right? So if the skewness or kurtosis, I mean, if you would like to test your data set is normally distributed or not, so it's very better if your result is less within the -1 to +1. In some cases, you can consider this one, but in extreme cases, you also can consider these values -3 to +3, right? So using the skewness and kurtosis, actually you can investigate the normal distribution. Okay, so next one, how to test for normality. Usually there are lots of options, right? But normally we use the histogram, and also we on the other hand we use the QQ plot, right? It's basically used maximum of the statistician, histogram and QQ plot, right? Okay, so in this way you can test the data normality. What is the how many statistical tests actually? Honestly, there are lots of statistical tests, right? Here you can see the 4 statistical tests: Shapiro Wilk test, Kolmogorov test, I mean KS test, right? Anderson Darling test, and the skewness and kurtosis test. So most popular test is like this one, the one sample KS test and the skewness and kurtosis test, right? So these are the most widely used test actually. So if you would like to see the practice of uh, statistical test, how you will test the normality, so there is another video actually in this series, right? So you can using the SPSS, how we can test the statistical, how we can do the statistical test or perform this one sample case test and the skewness and kurtosis test, right? So the skewness and kurtosis test. Okay, okay, in this way we can do the statistical test, right? Result actually. So in this result, we normally test this one. We normally test this one. Asymptotic size distribution tests. Please see here all the values are less than 0.05, means the variables are not normally distributed. When the value will be greater than 0.005, in that case you can say the variables, right, or predicted variables or dependent variables, I mean what variables you are talking about, are normally distributed if the p-value, I mean the significant value, is greater than 0.05. Otherwise, in this case, all the values are less than 0.05, it means data is not normally distributed, right? So to be honest, statistics, it's fun, but it's not easy to memorize or understand like this. Okay, thank you so much for your patience and participation, right? So in the next video I will try my best to show you some other statistical tools or practice. Okay, after the next video, okay, Allah Hafiz, bye bye.